Hey guys, these are your notes for solving quadratics by completing the square. Question 1. Solve algebraically for x by completing the square. Now remember, we only complete the square when the directions tell us to complete the square. And since the directions have told us to complete the square, dead giveaway, we will be completing the square to solve this thing. Excuse me. So step 1 is going to be to move the constant to the right-hand side. So you'll notice that this quadratic is given in standard form. What we want to do is move this guy over to the right-hand side. And the way we will do that is by adding 16 on both sides. That's exactly what happened here. Then, step 2 says make your area model. So we want to represent our area model of this left-hand side of the equation right here. So I have an x squared that's made by doing x times x, and then we have 6 x's all together, and I'm going to split 3 on each side. So this is me generating my area model on the right-hand side. Notice that this is not a square yet. In order to complete the square, we must add 9. And these are our 9 dots added right here. Step 4 is to add the magic number to both sides. We can't just add 9 here and then not add 9 on the other side. So that's what's happening right down here. What we do to one side, we have to do to the other, thus maintaining equality of the statement. Step 5 says to factor the left-hand side using your area model. So remember, in our area model, we love it so much because these become the factors, and since there's 2 of them, we can square them. So we factor this left-hand side polynomial to get a binomial squared. We then combine like terms on the right-hand side, and we now have chunk squared equals a constant. I then solve using square roots by square rooting both sides. The square root of x plus 3 squared becomes x plus 3. The square root of 25 is plus or minus 5. I then subtract 3, and I have my 2 answers. Positive 5 minus 3 gives me 2. Negative 5 minus 3 gives me negative 8. These are my 2 answers. Completing the square works because we literally make a square. So with all that kind of mumbo jumbo up there, let's do a question together. Use the method of completing the square. Ding, 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 ding. I will be completing the square. To determine the exact values. Exact means no decimals. Your answer will have square roots in it. Of x for the equation x squared plus 10x plus 7 equals 0. So what I'm going to do first is move the constant over to the right-hand side. I now have x squared plus 10x equals negative 7. I am then going to use the area model to represent this side of the equation. I will do that by doing an x squared. How do I make an x squared? X times x. I have 10 x's to split evenly on both sides. I'm going to do 5 and 5. I now need to complete the square. I'm going to draw out 25 dots in order to complete the square, but that feels a little insane, so I'm just going to add 25 here. Remember, it's always this number times this number, right? That completes a square. So since I have added 25 on this side to complete the square, I must add 25 on this side. I am now left with something that looks like this. Oops. Now I'm going to factor the left-hand side, and remember, your area model does it for you. It becomes x plus 5 squared. That's why we love the area model. And then 25 minus 7 is going to give me 18. I then square root both sides, and I get x plus 5 equals the square root of 18. The square root of 18 can be further simplified because it contains a perfect square of 9. In fact, 9 and 2 will be the 2 radicals that multiply together to get radical 18. When I take a square root, I put a plus or minus. The square root of 9 is plus or minus 3 radical 2. I'm now going to move the 5 over. And remember, we always put the constant into the front to prevent any sort of math errors. These are our solutions. Okay, bye.